Hi friends, welcome to my channel Cloud TV. As you all know, I am putting a lot of technical videos on this channel. Please subscribe to my channel to get more technical videos. Some of our friends who are new to Apache Spark has requested me to do videos on Spark basics. So today I am starting a new series called Apache Spark for Beginners. So in this series I will be teaching you about Spark basics like introduction and Apache Spark architecture and what are the abstraction layer or abstraction data types we are using in Spark like RDD, data frame, data set, and also I will be teaching about Spark SQL and Spark streaming basics for Spark streaming, structure streaming. Then we will be going to the machine learning library called Spark ML or MLlib. Earlier it is called MLlib. So we will be going step by step. Okay. And also parallelly I will be putting videos on scenario based videos on Spark as well as Hadoop. Okay, let's start with today we'll start with the Spark introduction. Okay, before starting the session, before going to the slide, let me minimize the recording window. Okay, done. So let me go to the slide. Okay, so Apache Spark for beginners. So we'll start with the introduction, architecture, RDD, data frame, data set, etc. Like the streaming, everything. Okay, Apache Spark. So people who are very new to this Spark. So Apache Spark is a unified engine for large scale data processing. Means before 1 decade before there was no solution for processing large amount of data like big data. We call it as big data, right? So if you want to say in simple word what is big data, whenever you can classify or you can characterize big data based on 3 main properties. One is volume, velocity and variety. Okay, volume nothing but if you have a huge amount of data in terms of volume, then it is called big data. Then another property is called velocity. Like velocity means if it's on speed and at which the data is getting generated. Like you can think of trade data, right? Trading data and the tweets in Twitter. So these are few of the example for the high velocity data. Like with the low throughput, there will be a lot of with high throughput, there will be a lot of data generating. So those kind of data we also call it as big data. Then another property is called variety. So so if you go to the web, so you see a lot of variety of data. So like unstructured data where you see the text document for your news. Okay, there are many stuff. So those are unstructured, and even videos and images are unstructured. And semi-structure, there is another variety called semi-structure where you see there are some delimiter data with the delimiter, some delimiter CSV data like XML. These are called semi-structure. And then another type of data is called structured data, where we analyze or will have data in the form of RDBMS tables. Okay, so the big data got introduced in the year 2004 in those times. So there was no engine or the processing framework for doing the big data processing. Then Google has found framework called Hadoop. Means the framework called actually the MapReduce for doing large scale processing. Okay, so from the Google concept. They actually released the white paper on their framework which they developed. So from that, the Hadoop community has inspired, and they developed the Hadoop. Okay, so when the Hadoop came, yeah, it is good. It is able to process the large amount of data, but it lacks in certain areas. Okay, so basically it was not able to do the computation in a very real time manner. Okay, so it's mostly for Hadoop is mostly meant for batch processing, and also it is sometimes some jobs are very slow. Okay, so to overcome those problems in the Hadoop framework, which like mainly in the terms of the parallel distributed computing. Okay, so Spark community has developed a framework called Apache Spark. Okay, so they have a special execution engine. Okay, it also uses the concept of same map and reduce phase and shuffle phase, but it is an efficient engine. Okay, so you can do a lot of computation in a faster manner. Okay, and it is also efficient, and it is not time consuming. It is very faster. Okay, so as a whole, if you see Apache Spark, okay, it has ecosystem components or libraries. Okay, so underlying is called Apache Spark or Core API. We call it as Core API, where you actually process your data in terms of abstraction called RDD. Okay, I will explain about RDD in the coming slide. Okay, then once they developed the core engine, then they started implementing the libraries for specific use cases. Like if you want to process the structured data, they introduced a Spark SQL as a library. For near real-time processing, they introduced Spark streaming. And for machine learning, to build machine learning applications, they build a MLlib or Spark ML library. For graph-based data, they used the graphics as a library to do that. So this is the overall the Spark ecosystem libraries or components. Okay, so we'll go a little deeper. What is the difference between Spark and Hadoop, mainly in terms of computation? Okay, so how it is improved, or how it is giving us improvised data processing engine compared to MapReduce. Okay, so if you take or if some of the people who are very new to Hadoop, so basically at the moment you just think of Hadoop is for distributed computing. Okay, and it has two main components. Okay, one is HDFS, Hadoop distributed file system, and another is a MapReduce. Okay, it is a distributed programming model which helps for big data computation. Okay, so you can think of that it's kind of divide and conquer mechanism. So instead of doing a processing on single machine, so we do the distributed computing on commodity of machines. Okay, so that you can actually minimize the computation time or the execution time. So you distribute your work to the different commodity machines, and once the workload is distributed, it will get executed on different nodes in your cluster. Okay, then once the task been done in terms of map and reduce, and there will be a shuffle phase also. And then the reduce phase, you combine your result, and then you get the output. So that is the MapReduce framework model. Okay, so those two are, you can actually to start with Hadoop, you need to know about HDFS and MapReduce just to compare with the Spark. Okay, so we'll actually compare Apache Spark and Apache Hadoop in terms of 4 key points. Okay, one is with respect to storage, and another is with respect to computational speed. Okay, computation and computational speed, and the fourth one is resource management. Okay, when you take the first point, with respect to storage, so Hadoop has a storage component, okay, so HDFS. So we saw it is a reliable and scalable storage solution for storing big data set. When you say the data set, it is here we call as the data, okay, large amount of data. Okay, so Hadoop has its own distributed storage component, but Apache Spark is not having any storage component. Apache Spark is only meant for computation. It has only computation framework. Okay, so it doesn't have any storage framework, but it uses the or leverages the existing solutions like HDFS, S3, and NoSQL databases like HBase, MongoDB, and etc. Okay, even RDB, some of the RDBMS sources, it has connectors. Okay, so that's how storage part is taken care. And with respect to computation, so as I told you, in Hadoop we have MapReduce. It's designed in the form of map and reduce phase to do your computation. In the Apache Spark, so this is where they actually thought, so why don't we improvise or create a new computational framework which can do the work faster and efficient way. Okay, more faster and efficient way. So they come up with a new computation framework called Apache Spark. Okay, so using that they were able to do this workload in the faster manner. Okay, then so we'll come to know what is the difference, how they achieve in the coming up slides. So when it comes to the third point, which is the computational speed, yes, Apache Hadoop is a fast, but it's mainly for batch oriented job. So compared to SQL or data warehousing queries which is running for daily, like if it's running for whole day, so using Apache's Hadoop, they were able to bring the loads into minutes of or hours. Okay, the jobs which are running in a day, a whole day, they are able to bring into the job execution time in hours, or in the couple of hours, in the couple of or in the some minutes of time. But using Spark, you can do much faster way. You can bring it into seconds. Okay. So in the amount of seconds, you can bring it. So if you go to the computational speed, if you want to know about computational speed, you just go to the Apache Spark org, the home page. So they say, compared to Hadoop and Spark, they were able to get 100% or 100 times faster than the Hadoop computation. What they done is with respect to the logistic regression. Okay, this benchmark is with respect to logistic regression. Okay, it's not for all kind of data load you get 100% speed, but there is a certain amount of data load or data processing you can get 100% faster. Okay, other workloads you can get up to 10% faster than the Hadoop job. Okay, so logistic regression is the one of the machine learning algorithm. Okay, where you can do the classification problem. You can solve the classification problem, like say example in your email application. You can see there is a algorithm, or there is a rule which can classify your email is spam or not spam. So those kind of binary classification you can do using logistic regression. So when they did the benchmark for logistic regression in Hadoop and Spark, in Spark they were able to get 100 times faster than the Hadoop. So that's the computational speed you get it in the Apache Spark. Okay, and then fourth point is the resource management. Okay, so in the resource management, so Hadoop has a resource management called Yarn, which is yet another resource negotiator. It's specially designed for the maintaining resource in your cluster. When I say resource, it is computational for computation, which is CPU and memory. Okay, So when it comes to the Apache Spark has its own standalone cluster manager. We call it as cluster manager or the resource management tool, you can say, but generally the people call it as cluster manager. So it has a standalone cluster manager, but you can actually use the yarn, or there is other resource managers available, which we will discuss in the coming up slide. Okay, that's what I want to highlight on the two broad classification between Apache Spark and Apache Hadoop. Okay, next we'll try to find out what is the issue or the lacking area in the Hadoop with respect to iterative machine learning, and mainly the two areas. One is iterative machine learning and interactive data analysis. Okay, what is iterative machine learning? Basically, if you take a very machine learning algorithm, there will be a data set. Okay, on the data set you want to implement a specific algorithm. Take example of logistic regression or the linear regression or any other the machine learning algorithm you want to do the implementation. So what will happen is on the data set the algorithm will run on multiple iterations. Okay, there will be multiple iterations, then you get intermediate data. With that intermediate data you do multiple operations or iteration. So if you take each iteration, so you need to rely on the previous iteration result. Okay, that we were not able to do it in the MapReduce. So what will happen is MapReduce, if you take a MapReduce job, so that job will take input and it will generate output. But after that it cannot do anything. So again you need to develop with another job which will take this the intermediate data or the result of previous job. So previous job will write the result into again the disk HDFS or any distributed storage, right? It cannot store the intermediate value in any persistent storage, means it cannot have it in the memory. Okay, so you need to write into the again disk. The next job should take from the disk. So there are multiple if you have multiple jobs or multiple iterations you want to do, that many number of jobs you need to create, and you have to write those intermediate data into disk and read. So there will be a lot of IO operation needed. So that's where the Hadoop is one of the area it is lacking. So that is being resolved using Apache Spark. So what you can do is I can actually when you generate the intermediate data, like first job result. Okay, if the second job want to take first job result, so you can actually store your intermediate data in the memory, so that you don't need to read and write from the disk, which will actually improve the performance of the job and in efficient way. Okay, so intermediate data can be stored in the memory, so that next job will take from that. So you can do a lot of iteration using the data which is available in the memory. So that way the speed is increased, and you can complete the job in a faster manner. And next area where Hadoop lacks is interactive data analysis. Okay, so if you want to actually find out a particular say you have sales data for 1 month. Okay, so you want to do quick analysis and find out which actually store is making good revenue, or which store has generated more sales. So if you want to find out a quick insights from their data, so in Hadoop we cannot do that. So we can do using Hive queries, but still it is slower because of it cannot do much optimization. But again in the Apache Spark, so Apache Spark basically it will actually based on your job. Okay, so basically based on the number of computation you want to do, the Spark execution engine will optimize your operation, and it will run your job in efficient way, and it will be very faster also. So it has very rich set of functions to do data analysis. So in MapReduce you can do only map. So you can do calculation on the map method and reduce method. That's it. You cannot do much about it. Anything you cannot do much in the MapReduce. but here in Spark you have rich set of functions. Okay, so using that you can speed up the data analysis. Okay, and also you can cache your data in memory. Okay, so that's how Spark will improvise the lacking area in Hadoop. Okay, so the next thing is we want to understand how Spark is giving us the execution. Okay, so in the faster manner. Okay, so how it is able to execute our job in efficient manner. So we'll try to understand that. Okay, so as I told you, Spark has the special execution engine. Okay, so using that it was able to give the do the computation in faster manner. And apart from that, so when you heard about Apache Spark, the people used to say it is in-memory computation. Okay, what is in-memory computation? Okay, so when you heard about in-memory computation, so Spark does in-memory computation in distributed scale, which means, see, any application you take, say example, I written a simple Python program, okay, to do simple adding or subtracting two numbers. Okay, so when you executing the Python program, what happens is your data is taken to the memory, then it will do the computation and display the result, right? So all the application will take your data into memory. Okay, that is no change in that kind of mechanism. Same in Spark also. But what is the Spark giving is when you take your data set into memory, it is not in the single machine's memory. Okay, it is able to bring your data into the memory. Okay, in a cluster of machines. Okay, it's not one machines or one node memory it is utilizing. It is able to utilize the memory in the number of nodes in your cluster. Okay, so it is able to bring your data as in partition manner. Okay, so it is able to partition your data. Okay, and bring into the memory of multiple nodes, and that's how it is able to utilize the memory. Okay, cache the data into memory. That is called in-memory computation. So it is also doing the same way normal application do, but it is able to use the memory in distributed manner, not in the terms of single machine memory utilization. It will use the multiple machines memory. Okay, using the concept of the RDD and data frame and data set. Okay, so we'll go in detail in that. So what you need to understand is, so Spark will be able to utilize your memory in a set of commodity machines. Okay, so not on the single machine. So that's what you need to understand that. So it has an abstraction layer which can bring your data set in partition manner to the memory and do the computation. That's what you want to understand on the in-memory computation. Then we'll see very detailed on how the Spark execution engine does your computation. So when you write a program, okay, what happens is the program actually the Spark execution engine takes your program and it translates the user code into series of tasks. Okay, the task or operation is DAG in nature. Okay, so when you talk to people about Spark, they say Spark actually do the execution in terms of DAG. Okay, so they say in DAG manner. What is DAG? DAG is a directed acyclic graph. Okay, so all your series of tasks are DAG in nature. That meaning one execution, basically the flow of execution goes from one task to another task. So it will not come back to the same task and re-execute it. So it is not a cyclic manner, it is a acyclic manner. So from one task it will start and go to second task, third task, fourth task, and compute the result or store the result into the any output storage you specify. So that's how it is uses the the series of task execution. Okay, so it will prepare a program into logical plan, then physical plan, then it will generate the task. Okay, in logical and physical plan, it does the maximum optimization, how it can execute your task in efficient way. So a set of tasks will be generated. That task will be run on the Spark cluster. Okay, Spark cluster. Each task will run on the each executor. So executor in Spark, you can think of it's one of the JVM process. Okay, so you will have multiple executors to execute your task in parallel. Okay, that's how it will be able to execute your task in parallel, like our MapReduce does. It will be able to run the MapReduce, but in efficient manner. That's how it is able to do the job in quicker manner. Okay, then Spark achieves the this tracking of each operation like this. So it is going to build the DAG, right? So the task will be in terms of DAG, right? So how it is building is based on the new abstraction layer called RDD. Okay, the new concept called RDD. The RDD means it's a resilient and distributed data set. Okay, so it will if there is a failure on your data flow, so it can able to regenerate your data, or regenerate your flow of execution. Okay, using the lineage. So it will have the track of operations or the transformation it is going to do, and you can be able to rebuild the transformation or the operation you want to do whenever the failure occurs. Okay, and also they build a new architecture. Okay, to improve the speed and efficiency of your Spark job. So we'll see very detailed session on how Spark architecture works. Okay, so we'll see. So we saw, right? So the core abstraction in Apache Spark is the RDD, right? So we'll go a little deeper into our short introduction on RDD, and in coming up class we'll go very deep study of RDD. Okay, so when I say RDD, I told you in the previous slide, RDD is a resilient distributed data set. Okay, so whatever the data in RDD, it's immutable. You cannot modify it. Basically, you can actually, if you load data into one RDD, from that RDD you can derive, you can do some operation, and you can derive new RDD. You cannot modify that RDD, so it is immutable in nature, and it is a partitioned collection of elements that can be operated on parallel. So this is the way the Spark is able to process your data in parallel manner, because your data will be splitted. Like in HDFS, whenever you store a file, the file will get broken into a series of chunk or blocks, right? So similarly, your data will be partitioned. So each partition you can run it on multiple machines and do the computation. So RDD is a immutable partitioned collection of elements that can be operated on in parallel. Okay, so when you say if you look at the right hand, the image in the right hand side. Okay, so whenever you read, there is something called Spark context. Okay, that is used to connect your Spark cluster to run your tasks. Okay, we'll see in detail about in later session. So in the Spark context, you have a method called text file to read the text file. Okay, when you read a text file, the content in the text file will be able to get the data from the text file, and this sc.text file will create a RDD, what called a text file. It will have all the values in the text file, then it will become RDD. Okay, say example, text file is the one of the RDD. Okay, this code is in Python. It's so Python with Spark, we call it as PySpark. Okay, this code is in PySpark. So so what happens is you get a RDD, okay, of all the data in the text file. Then once you get the RDD, as I told you, it is immutable, but you can actually do the operation on the RDD and derive a new RDD. So on RDD you can do two types of operations. One is a transformation. Okay, transformation in the sense which generates a new RDD from the existing RDD or create new RDD. So say example, I read the data from the file, then I will have all the say example, it is a text file which has 10 lines. Okay, so 10 lines will be in this RDD. So I want to filter few lines which has a spark, okay, which has a spark keyword or word in the line. Okay, I want to take only the lines which has spark word. Okay, so I can do the filter operation. So that operation, filter operation, is called a transformation. When you do the transformation, you get new RDD. Okay, so lines with the spark is another RDD which is derived from the text file RDD. Okay, so every time you do transformation RDD, you get a new RDD. Okay, so okay, what is the other type of operation? That is called actions. So action generally, which when you do action, which returns a value to the driver program after running the computation on the RDD. So if you want to actually see that lines which has spark word, so you need to do you want to see the output, right? So you need to do the action operation. So example, collect is one of the operation. When you do collect, all the data will be computed in the RDD, and it will return you the result. Okay, it will return the value to the driver program. What is driver program? Then generally what happens is when you write a program, there will be a driver process which will be created. That process will convert your code into task, and it will negotiate the resource, and it will run your task in the Spark cluster. That we'll see more details about the driver in the coming up slide. It's a Spark architecture. Okay, so so what you need to understand in this from this slide is RDD. So you have rich APIs in Spark, right? So these transformation APIs are the functions, all the rich functions which is Spark is provided. So if you have RDD, you can perform two type of operation. One is transformation, another is action. So transformation will give you the new RDD. Okay, action will give it will run your execute your the transformation which is applied on the RDD, and it will give the result. Okay, that's what you need to understand this. So at this moment I will stop here. Okay, so what we learned in this session is basically what is Spark, okay, and what is the comparison between Spark and Hadoop. So what are the areas Spark has been improved, and what are the areas it is using the existing components like the storage components. And we saw two areas Spark is lacking in iterative machine learning and interactive data analysis, how it has been improved in the Spark. And we saw how Spark is faster compared to how the Spark achieves the fast computation compared to the Spark. And we saw it uses the in-memory computing, in-memory computation, and also it uses the Spark execution engine which runs your job in efficient manner on the Spark cluster. So basically by doing the logical plan and physical plan, and generate series of tasks in tag manner, and it will run the task in your Spark cluster in parallel manner. Okay, so and we saw what is RDD and what is the two type of operation we can do on RDD. So the next session we will see how the Spark architecture works. Okay, so that you can understand how the resource being, how your program being generated as your program is getting generated as a series of tasks, and it is getting executed in a Spark cluster in parallel manner. We'll see in the next session. Thank you very much, friends. Please subscribe to my channel Cloud TV. Okay, thank you for people who subscribed already, and I request people to subscribe my channel to get more technical content on from my channel. Thank you so much, friends.